Welcome to another episode of our Eros Lomboy Pro series. For today's webinar or for today's vlog, we will be describing about maestro cochlear implant fitting, specifically switching on Rondo2 audio processor. For those who are new in this channel, my name is Eros Lomboy. I am the clinical representative or clinical audiologist and sales representative for Medel Singapore. So if you're new to this channel and you like the content, please hit that subscribe button and notification bell for further updates in regards with our Pro Series playlist. So to start off first, let's begin with our table of contents. Okay. So our content for today is fitting overview. First fitting, follow-up fitting, and of course our general fitting aspects. Unfortunately for today, we won't be describing follow-up fitting, which I believe this should be our next topic for our next vlog, okay, for our next episode. So to start off first, we would need a patient who has cochlear implant. Otherwise, if we don't have any implants or any recipients with implants, we won't be able to do our switch on. So for our switch on, usually it starts as, or we consider it as week 0, and depending on the clinic and the hospital, usually for our standard protocol, we switch the patient during the 4th week or after a month. In terms of this graph, it is intended as a reference, not a rule or a procedure to follow. It's really dependent on the protocol or the standards that the hospital is abiding or following. In this graph, usually we always suggest to provide this information to your clients that the hearing through the cochlear implant is quite different from using their hearing aids. So hearing aids, after the initial fitting, we let the patient acclimatize. Somehow for hearing implant is quite different because upon switching them on, the sound quality will never be the same as the one with their natural hearing. Okay, it will. We need some time for the brain to adjust or reconfigure itself to be able to understand speech. So in the first stage, we let the patient hear all sounds in the environment. The more sounds that they register in their brain, the better the outcome would be. So initially in this stage, the patient need to spend 2 to 6 months up to a year to understand the environment using their cochlear implant processor. Over a period of time, they will be able to provide meaning to those sounds that they hear, and eventually they will be able to hear speech. Okay, then on the last or the hierarchy or the most difficult part of the process is for them to understand phone call conversation, the voices from the TV set, from the radio, and other devices or gadgets that are available to the patient. In terms of our audiogram, okay, in our initial fitting, we would like to emphasize that we should test our patient unaided, using an aided test. This will give us as a starting point where we will provide the patient with progressive maps. Okay, it is also a good practice that to do this so that if in case the patient has residual hearing, they will be able, or we will be able to know whether the quality of the surgery is good and if the doctor or the surgeon have managed to preserve some or the residual hearing of the patient. the main intention of our programming is for us to elevate the aided scores of the patient up to or until we reach the mark of 25 decibels to 35 decibels. Okay. So in terms of why 25 to 35, why not 25 and above? Because for Medel, our coding strategy needs to be at this level for it to become effective. Okay, and of course, once we reach our target, later on, we could fine-tune this for the sake of perceiving quality in terms of our or in terms of quality of sounds that the patient would be able to hear. Now, for first fitting, we also considered first mapping, first fitting as our switch on. Okay, just like what I mentioned during the introduction, I have mentioned there that in terms of this vlog, we are talking about switching on Rondo2 audio processor. To start off first, we need to assemble the interface box or our programming box. And in this scenario, since we'll be using Rondo2, we will be using our Max box here, connect it to our USB here, and the things that we would need is our Rondo2 programming cable and our ebony telemetry coil. Okay. After we assemble and attach our Maestro interface box to our computer, that's the time or the only time that we should open our software. The reason why we're doing like that is because if you start opening your software first without attaching your hardware box, there will be a problem in terms of detecting your audio processors. So to make our workflow efficient, this or the intention of this vlog also is to guide you on how to make your workflow faster. Okay, so remember, attach first the Max interface box before opening your software. After opening your software, you need to check the settings. Make sure that your make sure that this highlighted or this option only use the telemetry socket for objective measure has a check mark. Okay, the reason why we're doing this is even though in paper Rondo2 is able to do impedance field testing using the processor, from time to time, because of the weight of the processor, there is some sort of like coupling issue between the implant and the processor. So to avoid that, make sure that we use our telemetry socket for objective measures. Now in our interface screen, you could actually see here these 3 circles. It is important that these 3 circles is present, because if it's absent, it means that you're not connected or the interface box is not connected to your software. Okay. Now to create a profile, first we have an option. We could enter it manually, or we could import the exported intraoperative files that was sent to you by the Medel Singapore staff. Okay. For the sake of creating our in-depth learning in regards with the use of Medel, you could actually create manually by clicking new. Okay, and then here there are some items that are highlighted. The reason why they're highlighted is because they are important. if you manage to finish the asterisk portion or filling up the asterisk portion of this personal details of your patient, that's the only time that the implant section will be open for you to be able to edit or input the patient's processor and hearing aids, okay, and also your implants as well. Okay, after that one, if you click the plus sign, the details of the implant should be input. You could input there the surgical date, the type of electrode, the housing of the implant, and for the sake of learning, we will be focusing more on the basic fitting. So all you have to do now is just click save and close. Okay. For the meantime, we disregard first this import anatomy data, which will be another content for our vlog. Now, to connect our processor, make sure that it is turned off. Okay, off. Okay, open the latch at the back of the processor and connect it using our Rondo2 programming cable. So after connecting, okay, let's say for example this is your patient, John Doe. Click the start session and it will ask you which side would you like to do the fitting. Okay, after that, our fitting will have these following steps. We have our impedance field telemetry, fitting, configuration, and lastly, after configuring the programs, is we need to help the patient understand how to use the product. So for impedance field telemetry, okay, impedance field telemetry is quite straightforward. So here in the video, you could actually see here our session box, wherein it is arranged in such manner that some sort of like in a chronological order. Okay, so first thing that we need to do first is what we call telemetry or impedance field telemetry. We do that by clicking the highlighted plus sign in the right side of the screen. Why do we do IFT? The purpose of this one is to check the integrity of the implant and as well as to set the permissible amount of electric current that we would need to stimulate the cochlea. So to do that, we need to use our ebony color telemetric coil. Make sure that this socket is connected to the gray portion or gray female socket of your interface box. So for the coil, we need to put it on the patient's head and we start to click measure. Okay. Upon clicking measure, what will happen is there will be a readout wherein status will indicate if there is any electrode that are faulty or high impedance or short circuit. Okay. You could also click the small box to check previous IFT, especially what was done in the operating theaters. It will tell you the integrity of your implant and also the coupling. Coupling is basically the communication between your software or let's say your computer and the implant inside, if they're communicating well. Okay. The most important one to make the measurement take effect on our fitting is we need to save and close by clicking this icon in your toolbox or tool header. Okay. For fitting, after our telemetry, you could actually see here some green marks, meaning that telemetry is done. Now to proceed with fitting, click the plus sign in your program number 1. Okay. So before we begin, I want to emphasize about the dynamic range. So when we're talking about dynamic range, it's the maximum level where the patient could able to hear and the level where the patient cannot hear. Okay, so that's the dynamic range of the patient. from cannot hear to the maximum. Okay, it's some sort of like setting up the volume from 0 to 100%. Okay, it's the same graph as you could see here in our slide. So once we have a readout, the benefit of this one is we create a compliance line for the patient or for our fitting. So once our MCL hits that line, what happened was instead of increasing the amount of or the intensity of the current unit, the one that we are adjusting now is the pulse width. Okay, so it is automatic, it's built in, so you don't need to worry if you're increasing too much your MCL levels. What is happening is, since the compliance will tell you that this is only the safe range, what we need to do now is to increase the width of the pulse, as you could see here in our video. Okay, the more we increase, of course, the pulse rate or the program will become slower. Okay, the slower our program, of course, there will be repercussion in terms of quality. That's why with the new coding strategy, it's faster compared to the past 3 coding strategies that Midel have. Okay. For strategy, we keep it as default. Coding strategy have different or it's always there in the software, so you don't need to worry. Now, in terms of frequency band, always make sure to put it on maximum, which is minimum 70 Hz for low frequency, and then maximum would be 8500 Hz. For MAPLO, we also don't need to touch it for the meantime, because when we touch MAPLO, it's considered already fine-tuning. In terms of our dual stage sound management, what's happening behind the programming is as follows. Okay, of course, just like your compression, we want to extract speech. Then after extracting speech, we want to isolate speech so that the patient could hear clearly. Okay, this part of the compression sound management is by creating compression sensitivity. Okay, so as you can see here, if we make the compression high, the difference between loud sounds and soft sounds is somehow comparable. Okay, and then if we turn off the what do you call this, the compression rate, what happened is there are more sounds input from the environment. So how do we do it? So for us to be able to hear more, or to make the microphone more sensitive, we need to adjust the sensitivity. The higher the sensitivity, the greater the range without compromise with volume. So after that one, the second stage of our dual stage sound management is what we call MAPLO. Basically, for MAPLO, what we usually do is we stretch out the extracted speech to our dynamic range. So that's basically how we do our electric dynamic range. Now, for indicators, we could actually input there if we want some status light, or if you want to make it a little bit more private for your patient to remove the battery empty prompt, we could remove it as well. However, as per recommendation, we don't need to touch this because patient would need these indicators for them to be able to hear. Now, in terms of mapping, as you could see here, okay, the software is arranged, or the electrode is arranged similar with your audiogram. It is arranged from 1 to 12. Small numbers represent low frequency, high number would represent high frequencies. First thing that we need to check, your default volume at 90%, your minimum volume, and also your what do you call this, minimum volume and your maximum volume at 100%. Okay, so to begin with, let's understand how we map. here in our example, if we raise one level higher compared to the other electrode arrays, you could actually see here a sinusoid, okay, or a waveform. While if we increase all, we start to see here similar with our speech spectrum, okay. So to set up the dynamic range, you could search one by one their maximum level and their minimum level. You could also interpolate per channel. You can copy the shape based on your ECAP measurement. And the most popular one and the most fundamental amongst them all is to do flat maps. So for the sake of learning the basics, we'll start first with flat mapping. For a flat map, we could start at a level that is slightly higher than your impedance. So in your impedance, you could actually see here that the measurement is around 8. So we could pull out our setting at 10. Okay. So after doing that, we could save and close, and it will automatically be placed in program number 1. Okay. To test that program, you could actually turn on live by clicking this microphone and check whether the patient is able to hear using your program number 1. Okay. Afterwards, if it's done, all we have to do now is to create progressive maps. Okay, ideally we start first with a bigger step progressive maps so that a patient would be able to gradually increase their programs with slightly bigger step. Okay, so when you click progressive maps, it will automatically provide each program slot with different programs with high intensity. Okay, so after that, what we need to do now is for program number 4, we need to switch it on. Okay, the reason why we want to switch it on is for us to be able to see if they would be able to change their program later on, to give us a plan that if they're be able to accept program number 4, most likely that we would still need more mapping time for the patient to be able to reach our target of 25 to 35 decibels. So some summary. Okay, for fitting, we need to detect MCLs. Okay, if you want to do it manually, since we're doing flat maps, we don't need to balance it because most likely it's the same shape. For the rest of the values, it's already by right in the default volume, default setting. We don't need it. Okay, for each fitting, we need to activate the microphone so that you would be able to hear, or the patient would be able to hear the sound. And lastly, always save the map. Okay, that's the most important one, to save the map before you do anything else. Now for configuration, it's straightforward. All you have to do is just click this button to save all the programs inside. Now for fine-tuner setup, there is a small icon here that represents your remote control and also your coil, because you know our technology has a coil technology that will be able for us to provide patient with more indicating or indicators for them to use the device efficiently. Once you click that one, you will have more options here. The only thing that I would like to remind you is always turn your auto power off to off, not on, off. The reason of which is in the initial stage, we want to train the individuals or the adult or the child to turn off the device before they charge. Okay, we don't want them to be complacent that just putting the device while it's on in our charger, which will cause the battery to get damaged or spoiled. Now to configure your remote control and your processor, you need to put the or in terms of our remote control, always remember our programs. It is represented by a dot in your remote control. Okay. Now, during our first fitting, once we done our configuration and we close our session, for the processor, you need to connect it in the middle of your remote control or at the back of the remote control, and switch off and on to pair your remote control and your processor. Okay. You would know that the processor is synced if you see two amber lights on top of the processor, on the top of your fine tuner or your remote control. Now, in terms of product handling, okay, so for Rondo2 is a straightforward product. Okay, most likely the reason why it's also very impressive is that it's very low maintenance. Okay, as you will see, there's no parts. I think the only challenge for the patient is to get used to connecting the cable or the lanyard from the processor to the hair or to the clothes. Okay. In regards with charging, I want to re-emphasize that you need to turn off the device first before you charge. Minimum charging is 4 hours. You could leave it overnight. The good thing about the charging or wireless charging is it creates heat that will dry off your processor. Okay. So for general fitting aspects, for the meantime, we don't encourage fine-tuning because as much as possible, we want to hear them gradually from soft to loud so that the acceptance of using the device is better compared to providing them with too much amplification and at the end they don't want to use the device. For now, flat map is the most appropriate or fundamental mapping techniques that we could use for the patient. Okay, we only fine-tune it. Let's say, for example, we only fine-tune if we see some twitching or if there is uncomfortable, especially if we are using the traditional search for your MCL. Lock settings, especially for children. And basically, that's all for our today's episode. I hope you learned something new today. If this is relevant to you, please hit that subscribe button and share it to your colleagues and to those other aspiring middle implant specialists. Okay. Until then, hope to see you soon. Bye!